Hi, I'm John from Our Home from Scratch, and this is a video on table saws. Okay, so let's discuss some of the basics of table saws. My table saw is a Hitachi brand. It's a 10-inch table saw, which corresponds to the diameter of the blade. Almost all table saws you're going to buy use a 10-inch blade. This particular model is a contractor grade table saw. So if you're looking to purchase one, they tend to come in 3 or 4 different main categories. You have entry or hobby level ones, you have a contractor grade table saw, which what this model is, and then you get into the more expensive professional and cabinet saw grades, and those can be in the thousands of dollars. This particular saw probably cost me $300 or $400. You can get an entry level hobby saw for around $100 to $200. Some things to be aware of. They come with their own fence, so this is the fence here. I actually built this table around this table saw, excuse me, so I could increase the amount of the size of the wood I can cut, because if I'm building cabinets, I'm going to be cutting some plywood sheet goods, and they tend to be very long and very wide, so having a larger table for it really helps with that. Contractor grade table saws tend to be lightweight. This one's still powerful though, but it's got a thin stamped top here, so it's light enough that I can just pick it up by myself, and then they're really designed for portability. You can throw them in the back of your truck if you're a contractor, you can move them around the shop, whatever. So this particular table I just made in some recent posts, and I'll post a link to the post where I built this table, but this allows me to again cut some larger sheets. So most of the time you're working with a 10-inch blade with a the number of teeth depend upon what type of work you're doing. So 40 teeth is general all-purpose ripping boards, cutting. As you increase the number of teeth in the saw, the cut becomes finer. So if you're doing furniture building or cabinet building, you probably want to use something like a 60 or an 80 tooth count for ripping plywood or nice pieces of hardwood. As the number gets lower, it's more for just general cutting, and you're not really concerned too much about the quality. A lot of saws, when you buy them, will come with a 24 count tooth blade. So I've put a 40 on here, makes it a little more useful. But I probably should be using a 60 or 90 on here for cabinet building. The other thing is you can, right behind the blade here is called a riving or a riving knife. I'm not exactly sure how to say it, but it's a piece of metal that is roughly the same thickness as the blade, and as the workpiece you're pushing through here gets cut, this metal gets in the gap created by the blade, and it prevents the gap from closing back around on it. So what happens is, as you pass a piece of board here and it gets cut, sometimes the wood's going to want to pinch back together here, and if it pinches completely, the blade will actually grab it and throw it forward. So whenever you're cutting, I tend not to stand directly in front of here. I'm almost always standing to the side and pushing it through, so you can see like that. You almost never want to be standing in front of it, behind it. So this blade, this riving knife here, prevents that contact from occurring when you're pushing blades through. This particular table saw is not really designed to take dado blades, which is one of the drawbacks of this particular model. Dado blades are, you basically get to stack multiple blades together, and you lower this blade. So this is set up for a through cut. So no matter what piece of wood I'm putting through it, this is like a half-inch piece of wood here, for instance, it's going to cut right through it if I have it set to this height. But if I lower the blade such that the blade is less than the height of the wood, you can actually just put grooves in the wood without cutting through it. So to make wider and wider grooves, you would stack and stack blades until you get the desired thickness of the groove you want. But this particular saw, it doesn't really let me do that more than stack 2 or 3 of these blades. And if you want to cut, say, a 3/4 inch dado groove, you would need more than that. So you can tell by just looking at the specs on here, on the saw, if you're looking at a saw, how much dado blade it can handle. This is a blade guard. Okay, so as you're pushing pieces through, it prevents your fingers from coming in contact with this. Generally, whenever I'm working with this, I try to keep my hands pretty much off the saw So if I'm pushing something through, they don't really break the plane created here, like around this area. I try not to do that. To avoid doing that, you can use a push stick. Okay, so this one's thin enough that if I'm working with a thin piece of wood, I can push the material through without having my fingers get in this area at all. If you're working with dado blades or that sort of thing, this will have to come off, this driving knife has to come off because this is really only applicable for through cuts. But if we're putting a groove in here, this portion does not raise or lower. The blade does. So when we're doing a groove, this would just be in the way, so this would come back off and can be reapplied later. Couple things, they do have commercial grade fences. This is an aftermarket fence I bought several years ago from Lowe's. I think it's called Biesmeyer, but it's an awesome fence. Comes with this rail, so if you want to do your own upgrade system here, this is the nice model to use. There are a couple models that are equivalent, and in the links for the actual table, I have some links to similar products you can use for that. So let me show you the front of the table saw, what the basic buttons are and how it works, and then we'll make a couple sample cuts to show you what that's like. Alright, so this is the front of the table saw. So here we have an on-off switch. There's a reset button in case the motor on the saw gets bogged down and trips the breaker. It'll actually trip a breaker internal to here. This wheel, if you turn it, lowers and raises the saw from the saw bed. Okay, behind it there's a miter gauge, and right now it's set to 0. So when the blade is in the perpendicular direction to the table, it's at 0 degrees, and then it actually can sweep to 45 degrees. So the blade will start out at 0, it can go all the way to 45, and then you can cut 45-degree angles for miter cuts, things like picture frames, that kind of thing. Over here there's another wheel. Okay, right now it's locked, but that is what changes the blade angle. And behind this knob there's a secondary knob which locks the angle, whatever you set it to. So right now it's set to 0 degrees and it's locked. So if I were to come by and bump this, that blade's angle would not change. So that's kind of crucial. If the blade is off and it's not 0 degrees and you go to cut a board with it, and then you want to join it with another one, your results won't be great. So we give very basic overview of how this works. Alright, so let me show you how I set the blade to make sure it's accurate. So, to make sure I have this blade angle set to 0 degrees before I work, I need two things. I need a flashlight, okay, and then one of these. This came with a sliding ruler, and it has a square side, so this is 90 degrees to the bottom half. And what I'm going to do is I'm going to push it right against that saw, okay, and this then will be 90 degrees to this blade. If it's not, then I can adjust the blade angle, and I can verify I'm at 90 by putting a flashlight right behind it. And if I say had any light come out there or at the top, then I know the blade still needs some adjustments. But right now I've already set it up so there's no light coming from behind it, so I know this blade is 90 degrees to this work surface. So that's pretty much it for setting the blade pitch. The other thing we can do is adjust the fence. Alright, the other way we're going to calibrate our table saw is by adjusting the fence relative to the blade. So the blade can really, there's a couple adjustments we can make and a couple we discussed. So you can raise and lower the blade out of the table. You can change the angle of the blade through the control knob, and we used our square to make sure it was perpendicular to the table, or perfectly 90 degrees. So the other issue we have to worry about is whether the fence is open or closed or parallel to the blade. So if it's open, as you push through a workpiece, the piece is going to want to go away from it, and your cut won't be perfectly straight. If it's closed or closed in the back, what could happen is as you push it through, it's going to want to bind back here. And if you're not working with a riving knife, it could be ejected. And even if you are working with one, it could be ejected. So it's important that we get this right. In any case, you want your results to be quality. So what I'm going to do, and I've already adjusted this, just FYI, I have one of these T-tracks on the table saw for some type of like a miter gauge. And what I'm going to do is I'm going to line the fence up with it. Okay, so this edge and this T-track are perfectly smooth, or flush right there. And then I'm going to do is I'm going to lock the table saw down. And I'm going to feel and look to make sure that it's completely flush the whole way through. This is a very casual way of doing this, and it may not be 99.99% accurate, but it's pretty close. So if this were open down here or away, what I can do is the fence, almost every fence you buy or that comes with the saw, or the ones that you want add later, there's an adjustment knobs inside the fence someplace where you can open or close that angle. So right now it's set. So I'm assuming that when the manufacturer built this, the blade is equidistant from its own T-track. If it isn't equidistant from its own T-track, then whatever, and it's not going to work. But so just really quick, lets me to make sure that this distance is the same as this distance. Alright, so now we're ready to make some cuts. Okay, a quick word on personal protection equipment. Whenever you're working with power tools, make sure you're using eye protection and hearing protection as well. These things get really loud. The other thing I want to say is I may not be doing this 100% accurate or correct or safe or whatever, so the best thing to do for your own protection is to make sure you read the manufacturer's instructions that come with your equipment, follow safe work habits, because you don't want to get injured. But if you do, it ain't my fault. Okay, I've got my hearing and eye protection on. I've got my table saw set up. I've got my fence set to the right distance, and we'll go ahead and make a sample cut. Okay, just a couple thoughts on cutting boards. We just ran this one through. Whenever you're cutting a piece, most of the time you're doing a straight cut. You can do some angled jigs where the piece will actually go through at an angle if you want to do that. But for most straight cuts, and almost for all cuts, when you push this through, and as you're guiding the workpiece on, you want to keep an eye on a couple things. Number one, to make sure all your parts are away from the blade. Fingers and whatnot, and as you're pushing it through, you want to make sure that this gap is tight. See right there, you can barely see anything, and it actually, as I push this through, it actually starts to widen up a little bit, and this board may not be completely straight, but or completely square. And actually, if my riving knife is working right, which it is, I can't pull this back, okay, because the knife is grabbed. But the whole time you're pushing this through, you want to make sure this stays nice and tight. To make that easier, you could use a feather board in your T-track, which actually pushes the board over here on the uncut side as you push it through, and it actually keeps it snug and from walking away from the fence, because that can't happen. I'll just push that through. Okay, that's all I had in this video. If you have any questions or comments, or you think I'm doing this terribly wrong, you can leave a comment below in the video. And if you enjoyed the video, please subscribe to our YouTube channel and check out our blog, ourhomefromscratch.com. And our next video, we're going to be using the thickness planer to clean up the edges on some of our popular boards that we're using in our built-in project. So thanks for watching.